All right. Thank you for coming to my talk, and let's get started. So we'll talk about models using domain-driven design. By the way, I would like to mention that this talk was prepared without any usage of AI. I hope you appreciate that. And the organizers asked as well to put this URL and code just for you, where you can go and ask questions. I hope it's visible enough. All right, so first of all, I would like to mention what you won't learn today. All right, so you won't learn how to become a domain expert, domain modeling expert in 40 minutes. I know that it's impossible and it needs some practice, because I actually run training in architecture, domain-driven design, event storming, and other topics. My name is Vadzim. I'm a co-owner and instructor at Trinitech, where we run those training, and I work as well as a hands-on architect at Apotek One. Apotek One is the biggest pharmacy chain in Norway, and it's a part of Phoenix Group, which is presented in Poland as Pharma Polska. Some facts about my private life. I have a family, I live in Norway, and I enjoy nature, skiing, playing the guitar and singing. Yeah, by the way, I have a backup plan. If AI takes my job, I'll play the guitar in restaurants. I like fishing, working out. I've already found some outdoor gyms in the outside, so if you want to join, please give me a heads up. I love cars, and I like making some goodies for my family, and I like to do almost all of those things with my family. So let's move on. The plan for today is to talk about domain and models, because not everybody understands the kind of clear difference between domains and models. I'll give you a quick intro to tactical domain-driven design. I'll give you some more important tips for designing models and writing the code, and we'll talk about model persistence. All right, so now I'm gonna give you super fast intro to domain-driven design, because it's not a focus of this topic. However, I can't just skip it. So everything began with this guy, Eric Evans, a long time ago, and just a few points of domain-driven design, about domain-driven design. So it sets focus on solving real business problems. So that was like the main idea of it, the main motivation. Instead of focusing on technicalities, let's focus on solving real business problems. Next one is that domain-driven design makes communication better between people, teams, and departments. And it's addressed by ubiquitous language, which is kind of the main thing of domain-driven design, not bounded context, but ubiquitous language is the main thing. And domain-driven design helps distill the core of complex domain, which is it's as well like a nice thing, I would say. And DDD gives some tools and patterns to manage dependencies of the different parts of software systems, and it provides some tools on the code level as well, like just in the end, tactical domain-driven design. And most of the talk will be dedicated to tactical domain-driven design today. All right, so let's start with domain and models. And let's start with domain first. So what is domain? So domain is a sphere of knowledge. So it's a kind of huge knowledge about some area or sector, or maybe some process within the company. All right, so this is a domain, and domain provides the context for problem space, because in the same domain, in the same area, different companies may have different problems. So example of domains, let's say we may have meteorology, warehouse management, transportation, backend system. So many different domains. As you can see, it's like a huge knowledge about certain areas. And over here, we just slowly come to models. And here is kind of an example. Let's say we have a domain of banking and financial transaction, and we have a specific problem. So we need to detect and prevent fraudulent transactions in real time. And we may have possible solutions, yeah, which are covered by models. Yeah, so we can use different solutions for that: machine learning or rule-based systems, and maybe some others. Yeah. So as you can see, so here we just have come a bit to different models. So. Just one more example, what model to use. And we have domain, like a cartographic, geospatial data, transportation networks, and we have a specific problem, like route planning and navigation, and we need to assist users in efficient moving from one place to another, from point A to point B. So what kind of solution would you choose for that? Maybe you have it on your mobile phones. You can say it loudly. From moving point A to point B, what would you choose? I hope you have Google Maps in your mind, right? So I have a fun story about Google Maps. So some years ago, I and my wife were to mountains, and we decided to take some like an easy tour. It was 10-15 kilometers walking in mountains, and then after 1 hour of walking, we realized that we couldn't match the position on the Google Maps with the surroundings. Okay, so we decided to go back because it was a risk to get lost. So which means that Google Maps works perfectly for moving between point A to point B in cities and maybe between cities. However, in other contexts, it just simply doesn't work, which means that in different situations, probably you will choose another like a best fit, right? So, for example, as you can see, you have different choice. You have a various choice of different models, and maybe in some cases a physical map will be your perfect model. And we come to the conclusion that a model is actually a simplified representation of the domain, focusing on essential elements to address specific problems. All right. So model is a simplified representation of the domain, and it cannot capture every aspect of the reality, which means that all models are wrong. All models are wrong. However, some are useful. So for a very specific problem, you may find a very useful model. However, please don't try to implement a model that can be useful everywhere. It will be a waste of time. And models live in the solution space. So the domain provides you a problem space. You find specific problems, and then you will try to find a model that will solve those specific problems. But they don't capture every aspect of their reality. So let's talk about some risky models. One more example. Maybe some of you are working with kind of legacy big systems. Maybe some of you worked with those. So let's imagine you have a system that consists of a lot of different business capabilities, and everything is packed in one big monolithic system. Yeah, I hope some of you have experience with those systems. And what kind of model do you usually have in your database? In your database. So usually it looks like so, right? So it's just hundreds of tables, maybe thousands of tables, and it's trying to address all the business capabilities in one go. As a result, it's hard to work with this model. It's hard to maintain it, hard to make some changes, and as well usually you have some performance issues with those models. So instead of using those risky models, you should be able to somehow separate your systems in different parts, and every part should have its own like a small model, which is just convenient to work with. And then it will help you just to evolve your systems faster and safely. And in addition to that, you will be able to maintain control over the dependencies between different parts of your systems. Right? So prefer just keeping small models for every part of your system that don't touch each other. I mean the models, instead of doing something like that. Okay, so should we always build models ourselves? The answer is no, because sometimes it's easier to buy something off the shelf, and very kind of intuitive example can be a payment. So if you implement a system that needs to provide some, payment capabilities, so most probably you will buy it and you will integrate with some payment provider instead of implementing it yourself. All right. So domain-driven design just tells about that you should focus on the core of your business, and there you will put the most effort and time on implementing this, and instead of just putting your focus everywhere. So sometimes you don't need even build any model. You can just buy it off the shelf. A golden path of applying domain-driven design. First of all, we start with strategic domain-driven design, which means using ubiquitous language, bounded context, context map. So I won't go into details because this is now a focus on this of this talk. And then we go to tactical domain-driven design, where we actually implement solutions, but please not other way around. So my real experience, first experience working with domain-driven design was like so. Tech lead just called me and said, Vadzim, we're going to use domain-driven design. I said, oh, cool, yes. So what we will do? Yeah, first of all, you will go through the code and find all data access objects, classes, and extract interfaces from them and rename them to repositories. Then you will go to all our services and move logic from them to entities and call those services application services. All right, so we started with that. So you can imagine that we failed and we concluded that domain-driven design doesn't work. So that was my first experience. So please don't go to technicalities. Don't learn first tactical domain-driven design, but start with the strategic domain-driven design. This was a real story. Is there any good starting point? Just based on my experience, I love running event storming sessions because I see the value. It helps exploring complex domains together by all the people involved into the product or project. And I mean developers, testers, business analysts, project managers, subject matter experts, just whoever is involved, and it just shines there. So please just check it out. It's a very nice tool. Yeah. By the way, I had a talk about it last year at GeeCON as well. All right, so let's continue and go to a quick intro of the essentials of tactical domain-driven design. And we'll be talking about value objects, entities, and aggregates. Real quick about value objects. I think almost everybody have heard about it, so I will go really quickly through them. Value objects are defined by the values of their properties. Example, color red. So color red doesn't have any identity. It has maybe a representation of the color, or maybe 3 integers like RGB, right? And if we have one object color red and another object color red, so we can say that they are the same, right? Those are both red colors. If you want to create another color, we just don't go and change any properties inside the color red. We create another one. All right, so which means that value objects are immutable. They don't have any setters. You can't change them. They can be unit tested and then can contain a small pieces of business logic as well. For example, we have a price, and the price consists of account and currency. There is a constructor with just a small piece of business logic that said that, okay, so we want to round all the prices because we don't want to have, for example, price 100,999,999. So we just should have like only 2 digits after the decimal point. And as well, we just business decides that there should be no price under 0, below 0, right? So that's like a perfect example of the price. As I said, that should be unit tested, and you can easily write a unit test for that. Yeah, I love Spock framework. That's why I just want to just give you an example so you can see how readable the code is. So you just provide some input and expected amount, and everything just is written in Groovy, and you can format it in this way, and you can see like how easy is to test value objects. All right, so let's go to entities. Entities are a bit different beasts. They have a life cycle, which means that they are mutable, and they actually can change their internals. They can as well contain business logic. They have the identity, which is very different from value objects, and then as well can be unit tested. Classical example, let's imagine I have this car, and all right, why did I say let's imagine? This is actually my car, and let's imagine that I decided to make some changes, maybe to change some color, maybe I would like to change it to toxic green and put monster truck wheels on it. Will it be the same entity after that? Yes, it will be the same. It will be the same because I just changed some attributes of the entity. Let's imagine the colleague of mine decided to buy exactly the same BMW with all the specs, the same color. I just come to the office and I'm shocked. So I just can't understand what is my car doing here on the parking, because it should be at home. It was a colleague of mine who bought actually the same BMW for himself. And can we say that this is the same car, or those cars will be different? Those will be different, yes, because they have an identity. They have a VIN number, right? Even if they have the same, all the properties, all the specs are the same. So those are entities, all right? So they have identity, but the properties may have exactly the same values. And now we're going to aggregates. So it's a kind of a lot of text. I will quickly read it because just, just to know this, and then I will present you a picture. So aggregates are graph of objects defending business rules, or invariants. So invariants actually came from the mathematics, which means that something that always holds true. So I will use these invariants and business rules interchangeably. So aggregates are treated as a single unit. They access through one entity, aggregate root. They can contain entities and value objects, can be unit tested, and some like to think about them as a consistency boundary. So it's important to remember this consistency boundary wording. All right, so let's take a look at the picture. So we have an order that may consist of order lines. It has status and shipping address. So it's a very simple example. So in reality, you may have kind of more complicated structure, but just for the sake of example, I think it's okay. So this is a graph of objects. And why did we end up with this graph of objects? So we came to this solution because we have those pink circles. And each pink circle is our business rule or our invariant. For example, one of them says at least one order line, which means that an order should have at least one order line. It doesn't make sense to have an order without any order lines. One more, only one order line per book, right? So if we sell books, so we want, for example, we don't want domain-driven design quantity 1, domain-driven design quantity 1, domain-driven design quantity 1. We want to have only one order line, domain-driven design quantity 3. Make sense? Makes sense. And one more, for example, cancelled orders cannot be dispatched. So if you have already cancelled order, we shouldn't be able to dispatch it. All right? So this is, and because we have those invariants or business rules, because we have all of them, that's why we end up with the structure. So the structure is a consequence of maintaining those business rules, not other way around. We don't start with the structure and then try to adjust internals to business rules. So we start with understanding the business rules, and the consequence of that is the structure. So that's kind of important to understand when you are working with tactical domain-driven design. So the structure of it, we call it order aggregate. So it's an aggregate. This aggregate has a consistency boundary, which means that within the structure, we always maintain the consistency, which means that all the business rules are kept intact. We can't have one business rule failing and others working. All business rules should be correct. So that's why we call it like a consistency boundary. So here we have a consistency. One more is that this aggregate provides some public API. In Java, it can be just a public methods like dispatch, cancel, and others. And this is how we interact with our aggregates, so this API. In addition to that, we may have different types of objects, right? So order, for example, can be an entity, order line can be an entity as well, and we may have value objects. So in this example, I chose like that, but in your example, it can be different, but this is how we just assign different responsibilities to different objects. And in addition to that, we just mark order as with aggregate root label, okay? So in the whole object graph, we pick only one entity and say that this will be our aggregate root. And aggregate root is the entry point to calling business method on our aggregates. All right? So order is an aggregate, so it's a graph of objects. We have one entity, which is aggregate root, and if we want to perform any business operation, we call this aggregate root. Now, question, how many repositories should we have? Who goes for 2 repositories? Who goes for 1 repository? Yeah, so the correct answer is 1. Why is it 1? Let's imagine you have 2. All right, so you have order repository and order line repository. And then you perform a method, order line delete. If you remember this like a very first circle, at least one order line, then you may just break the whole aggregate. Or for example, you have order line save, then you may break the other one, only one order line per book. All right, so which means that when you're working with aggregates, we should usually have only one repository. Like in our case, it will be order aggregate, which will provide us an order, and we will call business operation of that order. And order will be at the same time entity and aggregate root. All right, so that was a kind of quick intro to main building blocks. And one thing that I would like to mention is that business logic exists inside aggregates. So I think everybody kind of resembles those like a beloved services, and maybe some of you work with these systems having multiple services, like with multiple methods, like a service A equals service B equals service C equals service A, because it was convenient method in the service A, so why not, right? So, and you have like a mess of those services. One time you get a bug to fix, and you've found out, oh, I need to add some if. And you add if only in one place because you're unaware of other places with the same bug. So I hope some of you are familiar with the situation. I worked with those legacy systems, and it looked like so. So instead of having this like a getter, get, set, just modify our models by the services, the business logic should exist inside our aggregates, because they keep the consistency. all right? And we just get access to the aggregate, and we just call some public method of the aggregate. For example, dispatch, and everything that should be implemented will exist inside the aggregate. Other more building blocks? Yes, domain services, specifications, repositories, and others. However, unfortunately, I had to just pick the main building blocks because of limited time. All right, so let's go to the next one, important tips for designing models. So the first tip is you shouldn't mirror the reality, because the reality is too complex, and you should focus on the problem you need to solve instead of mirroring the reality. So let's take a look at this example. We have a president and country, like two entities. So, and what kind of relations should we create for those two entities? If we take a look at the reality, in the reality, like each country may have many presidents, right? Belarus doesn't count, okay? It has one president. But like in general, they have many presidents. And one person can be a president of multiple countries as well, theoretically, yes? So which means that, all right, so we need to apply many to many. And if you go further, maybe you would like to have a history of presidentship and other relations. And in the end, you will be so proud that you created so nice and complex model that can tackle every aspect of the reality. But in the end, you will realize so how hard it's just to work with it, how hard is to change it, and it just doesn't solve the problem in an elegant way. So instead of it, and maybe in your context, you will need to solve the problem when you have a country and only current president. So maybe in your case, it will be just one-to-one relationship. And maybe in your context, it will be a specific country. So you won't need country at all. You will just need a president. So focus on the problem rather than on the a reality in general. All right, so you shouldn't mirror the reality. This is important thing to remember. Next one, it's okay to use CRUD with domain-driven design. And you can just ask me, all right, Vadzim, but you just presented us aggregates and all of those things building blocks of tactical domain-driven design. So why create, read, update, delete? We should use aggregates, right? Just tactical domain-driven design gives you just a toolbox. And maybe while building a system, you will realize that you have a part of the system that is so simple, so you just need to keep some data and just get access to it and nothing else. And you don't have any specific business rules. And in this case, it's just okay to use CRUD. So just consider tactical DDD as a toolbox. It doesn't mean that now you should go and use aggregates everywhere. Right? Maybe you will end up with completely different model, maybe not CRUD. Right? So the main focus of DDD is to solve business problem, but not to just just to consistently working on and building aggregates. One more, avoid bidirectional associations. In this example, we have an order which may have many order lines, and each order line is defined by an order, right? So it's just natural association. Order, have many order lines, each order lines refers back to order. And I remember a fun story with a very promising junior developer. So he created a part of the model where we applied bidirectional associations just literally everywhere. I asked why. The answer was because I could. And the documentation of GPA in Hibernate shows how to do that. It's so pity that there is no a warning. Please consider it whether you need it at all, right? Because it's it's an illusion of convenience. So people think that, oh, it's convenient because I can traverse my my domain model without any problem. I can go from anywhere to everywhere, right? And what is the result? So result is the increased complexity. So the more points, the more complex solution you have. It may be harder to maintain consistency because some business rules may look like, oh, I go from order to order line, and then I go back to order, and then I go back to order line, and then back to order. Don't ask why. Developers always have reason, right? You know that we always have reason. So if we have a possibility, we'll use this opportunity, right? So, and it may be harder to support this as well on the infrastructure level, like for example using some ORM tools, like to map your entities, because you may have those like a chicken egg problems when you need to persist something that refers to something else, but it doesn't have ID yet. So you need to generate this ID, then persist, and then only then you can persist that entity. And we start blaming ORM frameworks. They just don't work. They don't work well. They just they can't map our entities and things like that. So instead of it, prefer unidirectional associations, right? So just for many years, okay, I'm not that old, like for many years, I haven't seen any example where I needed bidirectional associations, except one, when I had a model that represented a graph, real graph, because I had to traverse the graph back and forth. So I needed to have those bidirectional associations. Other than that, no example. Next one. Throw away your first model and maybe the second one. So when you create a first model, so probably just consider it as a draft. You're just getting some knowledge, you're just understanding it. Maybe you just have done some mistakes, and that's fine. This is how our brains work. They need some data. You need to feed your brains with some data, and then you actually can maybe end up with a better model. So you shouldn't consider your model as your baby, all right? Because this baby then will become a vampire. They will just suck your time. Okay, so just start with some models, start with some draft, and it's okay just to throw the first and maybe the second attempt. And then you will get just better ideas, and you will come with much better solutions. Sometimes you need only one draft. So in my case, like after years of working with this tactical domain design, I usually kind of okay with the first draft, but I always throw it. Next one. Good models are born outside the office. So this is like usually concerns me. I sit in front of the screen, I try to model something, basically feeding my brain with initial data, then I go for a walk, maybe take a shower, and then I get this, oh, now I get this idea. And I go back and implement it. This is how our brains usually work. So they just unconsciously, they are unconsciously processing the knowledge and the data you give to them, all right? And then you just come with this idea, and then your consciousness realizes, oh, now I know how to do that. Right? So just don't sit in front of the screen until you get to the point. Just leave your working place and take a walk. There are more tips, like aggregates, whether aggregates can contain other aggregates and so on, but we have limited time. It just takes hours, so I had to just pick, some of them. Okay, so now important tips for writing code. So first of all, stick to the language. If you remember, I mentioned ubiquitous language in the very beginning, which means that if domain expert says account, you should have class account, not user. If domain expert says winning bit, you should have winning bit, not best bit or just bit with some property, like whether it's best. All right. Do you have this like a translation in your systems, where someone is talking about one thing and you go to your code base and there is like another name there? I hope like almost everyone have something, some kind of sort of this translation when talking with your subject matter experts. So please don't do this translation, just stick to the language, and what people are talking about should be presented in your code as well. Use value objects more often. For example, instead of having some first name and last name inside your class, just create a simple value object like a person name. Instead of having some price amount and price currency, create a simple object, value object, price. So why is it so? Like there is as well like a term called primitive obsession, when people are trying to use primitives like everywhere. So if you start using more and more value objects, then you can achieve some positive effects. For example, readability, right? Because instead of just going through this code and trying to calculate what means what, you will have a clear name for this, like a person name. All right, that's much better. Validation. You can put all of those simple validation rules inside those value objects, and value objects will be always valid when you want to use them. Encapsulation, kind of one of the most important principles of object-oriented programming, because the right logic will be located in the right place. Testing. If you want to test an entity that contains a value object, you will just focus on testing the logic inside that entity. But if you don't have value objects and all the properties will be inside the entity, then you will have more permutations, more tests inside your entity. So your test for the entity will be much bigger. All right? And the last one is maintenance. It's just easier to refactor, move classes around, rather than just move all of those properties together. Next one, think about behavior rather than private fields. Unfortunately, we are taught in our universities, like we create a class, what will be the next word? The next word. Private, exactly. So we have an auction, we have private list of bits. Why not? Because auction contains bits, right? So we just think about the structures. Let's take a look at what our tests say. So let's imagine we have a session with our subject matter experts. We try to write our test in one of the best testing framework called Spock. Okay, and we just ended up with okay. And when the bit is accepted, a new winning bit appears. All right, okay. And another one. The bit accepted and the winning bit is changed. Oh, okay. Are we talking here about list of bits? So we can create a method like a start with place bit. We use some language. Yeah, we stick to the language, new bit. And our conclusion, our consequence of maintaining those business rules will be just a simple property, winning bit. Instead of creating some list structures, then trying to find the last one in that list, or maybe the first one, maybe to sort them, and things like that, right? So just to maintain this rule, we just need a simple property and nothing else. So you create the properties or the fields in your classes as a consequence of maintaining the business rules. So you shouldn't start with them, right? So you start with defining the behavior like an API. Then you write a test that just represents requirements to your future model. You satisfy the test by the implementation, and you just verify the solution and consider improvements. Sounds like TDD, right? And it is TDD. There are more tips. I have only 10 minutes left, so just need to continue. How to persist models. So this is an important topic as well. And let's talk a bit about it. And first of all, be pragmatic. What does it mean? So on the one hand, you should avoid thinking about database tables, foreign keys, etc. Let's say you start modeling, start writing some Java classes, methods, adding some fields, and you're thinking, oh, how many tables will I have? Oh, maybe there will be the third table. And if I need to fix an issue in production system, I will have to run additional join, and maybe it will affect performance. Oh, I will create index, but I will create index here, and things like that. You just haven't started with implementing, like your model, and you're thinking about those tables. But you shouldn't think about them. You should focus on solving the problem. So you will persist it somehow afterwards. On the other hand, you should be aware of quality attributes applied to your system. So maybe you have so strict performance requirements that you can't just have like a you can't just create a model that will somehow be persisted to database, and maybe you will end up with completely different solution. Maybe you will use some actor framework. All right, so just seek for the balance. However, like for usual business applications, when you don't have those like a very strict performance requirements, so probably you don't need to think too much about database from the start. So think about behavior and be pragmatic. So seek for the balance. I've seen so many developers who are thinking about those additional mapping tables in a database just before they write any single line of code. And the price of being purist. Some may say, oh, you put an entity annotation on your class. It's infrastructure. You shouldn't do that. It's infrastructure. Why are you mixing infrastructure with a domain? And then my answer is that sometimes it's just fine. You should just answer a simple question. Does it help you or not? If it helps you, just use it. Again, there is a price of being purist. If you want to be a purist, and if you don't want to mix the infrastructure and domain model, you will have to have one domain model, you will have another model, which will be just annotated, and then you just will have more time, and you will have fun of doing mappings and things like that. But do you really need it? So in my case, I kind of, or some ORM frameworks or other frameworks may restrict you from doing all the things you want. For example, having some interfaces in your domain model and different implementations. So sometimes it's impossible to do this mapping. However, sometimes it's okay just to pay this price. All right, just consider this price of being purist. One more. You can as well consider memento. For example, it's just impossible to map your model to a database schema. And one real story, I had to work on the system where it was decided that we would use a database, and the database schema was just, like a constant. It was documented in Confluence as well. Confluence had, for each table, we had a Confluence page for each table. It was described in the Confluence. All foreign keys as well was a link to other pages in Confluence. So it was like that, like it was an architect that created this database, and I didn't have any choice. But the real model that we wanted to use was a graph model. So I had to use graph. But how to actually map this graph with this RDBMS? It was pretty hard. In this case, you can consider using memento, which means that basically you have an aggregate that does the job and contains business logic. However, when you need to persist it, it actually provides you a snapshot that can be easily mapped to a database. And when you need to kind of dehydrate the aggregate back, You basically go to your database, get snapshot, and then convert it back to aggregate. Now let's talk a bit about repositories. So the main characteristics of the repositories is that they keep domain knowledge away from the persistence framework. So usually they're just small interfaces, and they represent an explicit contract to access aggregate roots. So those are like the main let's say points when we are talking about the repositories. Keep away domain knowledge from the persistence and give access to aggregate roots. And typical usage of the repository is like we use a repository for get access to aggregate root. We call some business method on aggregate root, and in the end we apply the changes. So, and it's important to mention here that repositories are not for having hundreds of methods or maybe dozens of methods, for example, for reporting. So you have like give me this data and give me this data and find this data and get all ordered by, and you know, like you have like, it just looks like you just add those methods for reporting because client application needs it. So repositories are not for that, and in this case, if you need to grab your data from database in different ways, so probably you should consider just working with some projections, like maybe have another component that writes a native SQL, for example, or you can consider CQRS as well, so you have a separate read model where you can just take your data from. One more thing, repositories are not for having vague methods, like find all matching. Because if you have those methods, then you give a full control to your client side. All right? And then client decides, oh, I want to do this, I want to do that. And so what are consequences? So first of all, the implementation can be more complex. All right, you don't have full control in your domain model, and it can be hard actually to support all the wishes the client code has. Just adding some, maybe like and I want this and I want this and sort by something and something like that, and it just stops working, and you have fun with just supporting one more requirements. And instead of this, repository should reflect the domain language. Like, for example, if you have a special use case, so you just mirror it inside the repository. For example, find books to censor. This actually corresponds to use case, and the implementation will do the job instead of having a vague method and giving like all the control to the client. And you should as well avoid returning partial aggregates. And this basically, here we can go to the very first picture about aggregates when you need to maintain all the business rules. And if you return a partial aggregate, then it's a risk that you kind of can miss some business rules and you may end up with inconsistency. That's why aggregate always should be ready to use. Okay, so some conclusions. Domains provide the context for problem space. So models live in the solution space and they address specific problems. Okay, so I hope you have learned it. They address specific problems. All models are wrong, really. Those are wrong, so please don't try to implement right models. They should be just useful and small. Tactical DDD goes after strategic DDD. Tactical DDD provides a toolbox, nothing else, and you decide how to use it. We went through some building blocks and general tips. And the last one I would like to mention again, be pragmatic, right? Just don't be dogmatic, be pragmatic. So where to learn more? You can read books like Patterns, Principles, and Practices of Domain-Driven Design. I recommend this one, and I stole example of an auction from it. And you can as well watch some of our talks. I mean, my talk and my friend's talk about event storming and domain-driven design. And thank you very much. So if you need to download, so the slides are there, and you can contact me as well. Thank you. All right, so it's 5 seconds left, so I guess we don't have time for questions. So if you want, you can just come to me, and yeah, there was no question. So yeah, if you want just to come to me and we can discuss. Thank you very much.